On this show, we spend a lot of time talking about continuous integration, continuous delivery, data engineering, microservices. These are technologies that have been widely talked about for the last 5 to 10 years. And that means they are easy to adopt for startups that got founded in the last 5 to 10 years, but not necessarily for older enterprises. Within a large enterprise, it can be challenging to make significant changes to how technology is used. Many of the listeners might even take it for granted that your source code is going to be in Git. But if you work at an enterprise that started building software in 1981, you might be moving source code around on FTP servers or floppy disks. The difficulty of changing the technology within a large enterprise gets compounded by culture. Culture develops around specific technologies. That's one interpretation of Conway's law. That's the way that an organization uses software informs an organization's communication structure. So this is no surprise. If your organization manages code using FTP servers and floppy disks, it's going to slow down your innovation, and the software that you produce is going to reflect your communication culture as well, because it won't be able to update as quickly. Zhamak Dehghani is an engineer at ThoughtWorks, where she consults with enterprises to modernize their software and culture. Zhamak works on a blueprint that describes specific steps that an enterprise can take towards modernizing. Things like continuous integration, building a data pipeline, building a system of experimentation. In some ways, this conversation fits nicely with our shows about DevOps that we had a year ago, a few years ago. I guess we've had a ton of shows about DevOps. And it was great to talk to her about the conversations that she has with these large enterprises, because I know there are a lot of people who are listening to this show that work at a large enterprise that are doing their best to modernize. And I know it's a lot of work to modernize a large organization that has certain practices that have been around for a long time. Full disclosure, ThoughtWorks, where Zhamak works, is a sponsor of Software Engineering Daily. And to find all of our shows about DevOps and enterprise reinvention, you can download our apps, Software Engineering Daily apps for iOS or Android. These apps have all 650 of our episodes in a searchable format. We have recommendations and categories and related links and discussions around the episodes. It's all free and also open source. And if you're interested in getting involved in our open source community, we have lots of people working on the project. We do our best to be friendly and inviting to new people coming in looking for their first open source project. So no matter how large or small a contribution you want to make, we have quite an interesting platform and an interesting group of people that are really nice. You can find that project at github.com/softwareengineeringdaily. You can join our Slack, and you can send me an email at any time, jeff@softwareengineeringdaily.com. It'd be great to hear from you. And with that, let's get to this interview. Your company needs to build a new app, but you don't have the spare engineering resources. There are some technical people in your company who have time to build apps, but they're not engineers. They don't know JavaScript or iOS or Android, and that's where OutSystems comes in. OutSystems is a platform for building low-code apps. As an enterprise grows, it needs more and more apps to support different types of customers and internal employee use cases. Do you need to build an app for inventory management? Does your bank need a simple mobile app for mobile banking transactions? Do you need an app for visualizing your customer data? OutSystems has everything that you need to build, release, and update your apps without needing an expert engineer. And if you are an engineer, you will be massively productive with OutSystems. Find out how to get started with low-code apps today at outsystems.com/sedaily. There are videos showing how to use the OutSystems development platform and testimonials from enterprises like FICO, Mercedes-Benz, and Safeway. And I love to see new people exposed to software engineering. That's exactly what OutSystems does. OutSystems enables you to quickly build web and mobile applications, whether you are an engineer or not. Check out how to build low-code apps by going to outsystems.com/sedaily. Thank you to OutSystems for being a new sponsor of Software Engineering Daily, and you're building something that's really cool and very much needed in the world. So thank you, OutSystems. Zhamak Dehghani works with ThoughtWorks. Zhamak, welcome to Software Engineering Daily.
Thank you, Jeff. Thanks for having me.
Absolutely. So 2017 is wrapping up. It will be 2018 when this airs, and you've been doing software engineering with ThoughtWorks for a while. And a lot of what ThoughtWorks does is work with larger enterprises to help them figure out how to migrate their software. So what is it like to be an enterprise going through a large-scale software migration these days?
Yeah, good question. I mean, all of the enterprises I come across, they are going into some form of a migration. We can talk about the motivation as why that's happening. A lot of them, there was a really good report from HBR about more than 50% of the executive and board members feel that more than half of their revenue is going to be threatened by the digital disruptors. So there is a real threat to industrial kind of organizations, industrial area organizations with the digital disruption. And that's triggering kind of migration, not only the technology is to meet the business strategy, but also business strategy. And I think we are at a very interesting point in terms of how the technology has evolved and where we are in terms of applying the new ways of doing software, building software that we see enterprises kind of adopting. But it's exciting. It's frightening. The change always, has a bit of resistance from the immune system of the environment. But I think it's an exciting time to go through technology transformation.
When you sit down with an enterprise that has an out-of-date technology stack, which is a lot of enterprises, even newer companies, your technology stack goes out of date in a year and you're always updating something. But how do you decide what to prioritize when you get a client that is like a really large enterprise and a lot of their surface area is out of date? What do you prioritize?
Yeah, absolutely. I think for us, we always think about the customer value, the mission of the enterprise, what are they actually trying to do. So when we do technology strategy or migration strategy, we always look at their business strategy and what they have in the pipeline. And we start with those. So we start with the domain within the enterprise that will have a high impact. The technology change will have a high impact on their customers. You start with a domain that is maybe kind of more ready in terms of the transformation. And, we go from there. Usually the transformation, you try to localize it to kind of a domain and start building from there. We think about, even when we think about organizational wide platform change, everything from your delivery infrastructure, your compute engine, your data structure, infrastructure, your services APIs, we always start with recognizing what capabilities you need to change, going through your customer journeys, going through your business, product backlog, and pick a thin slice to drive that sort of transformation, as opposed to kind of a bottom-up transformation that at the end of the day may not deliver any value to anybody.
So it's not necessarily around what is the most important aspect of our business and let's refactor the technology there. It actually might be the opposite. It might be what is the least important? What can we do that is the easiest? How can we perhaps get a win under our belt and prove to the rest of the organization that this is possible?
Yeah, I mean, absolutely. That's definitely a case, but it also depends on where we come and talk to the organization in their transformation journey. Sometimes, there is a new leader that is pushing for the change and he or she is looking for a very visible and high impact kind of low hanging fruit to show what it can be done and get trust from the rest of organization and, push the agenda further. Sometimes we join the organization when they are way through some form of a platform, change or technology change, and they're asking us to come in and help them within their journey. So they've already bought into the idea. They probably have some metrics at the executive level in terms of, the volume of the traffic that needs to go through their new platform. And they just now need help to roll that out. So yeah, it depends where you are. But if you're really early in your transformation journey, you really want to win the organization trust and show value quickly.
There are both cultural barriers and technological barriers. Do you take those separately? Do you try to reformat the culture and then reformat the technology separately? Or do you try to bundle those together somehow and reconfigure how an organization works all at once?
Yeah, absolutely. It's a very good question. I think the engineering organization, the culture, how the team gets set up, it's all very intertwined with technology. It's hard to do one without the other. We've recognized that in our practices. So for instance, like if we don't go in to just prescribe a technology strategy and leave, we think that, the culture change happens with showing how things are done, by coaching through doing and demonstration of how to deliver value, how to deliver, kind of software, make the organizational change, the team structure change incrementally, gradually, by forming the new teams or the new structure and go from there. But everything is very closely, tightly coupled. It's hard to do one without the other. The million-dollar question is that when you're dealing with a large organization, how do you scale that type of change?
So what's the answer to that? How do you scale that change? By the way, when you start with an enterprise, are you sitting down with one specific person at the company, or do you engage with the entire team altogether? How do you sow the seeds for what will eventually, hopefully, be a scalable change in the enterprise?
Yeah, absolutely. We sit at all levels. I think the change requires grassroots movement and top-down executive support. So you really need support from top, and you need support and buy-in at the grassroots root and engineers level. So once we get engaged, first, we really want to understand the landscape we're in, the dynamic between, different parts of the organization, the maturity of the technology they have, the capabilities of the developers. So we do quite a thorough assessment of where we're going in, and we be respectful of the constraints that the organization have and the challenges that they have. So we talk at the executive level, at the CTO level, CIO level, all the way down, pairing with the developers and seeing, the pain that they're going through, the friction that they have day to day to be able to deliver software. We talk also to the business side of the enterprise. I mean, these days, CIOs are more business focused than being just the, tech heads, functional heads of organizations. So talking to the business to see what's their vision, where they want to go, and how technology can support and accelerate that vision. So we kind of engage at all levels.
ThoughtWorks has a blueprint for the steps in the different areas where you can add value to modernize an enterprise. And I want to go through some of these aspects of the blueprint. And the area that I actually hear companies start with a lot is, so first of all, sometimes I hear companies don't even have like a version control system in place. Like they'll be sending files to each other over FTP, or saving files onto disks and then sharing the disks with each other and stuff like that. And that's probably a huge problem that you would want to start with if a company had that sort of issue. But I think we'll skip that one and maybe just say, assuming a company has version control, I think that's probably the first step you need to get to a CD system, continuous integration, continuous deployment system. How do you ease an enterprise onto a continuous deployment system?
Sure. So, you have to do it while you're delivering software. So we can't just practice continuous delivery without delivering something that needs to be continuously delivered. So we usually pick, let's say, a team, a feature, and then we go, okay, let's put in the infrastructure that you need to be able to continuously deliver those features. So version control, we've already talked about that. We do have some sort of a maturity model, the continuous delivery maturity model, where we look at the different aspects of the continuous delivery, source control being one, continuous continuous integration being another, configuration management, another aspect of that. So we go through that maturity model or different aspects that need to be implemented. And we will have people who have capabilities to build the infrastructure, to set up the infrastructure for the teams and, slowly build a pipeline. So you may start with a smaller pipeline that runs, that code that you had, you need to get your code under test. So, start with, some functional test or some unit tests, get the code under test, add the test to the pipeline. Then you go into, be able to release it to different environments, build the deployment scripts to be able to release that. So building that whole infrastructure through delivering value through the pipeline and setting that up and be able to kind of show and prove as you go along. So we will have people who are capable in setting up the delivery infrastructure, setting up the CD agents, building some starter kits for developers to be able to get up and running more quickly. Because what we want to also avoid is having a central team who's now responsible, centrally for your build pipelines. That's a very slippery slope to getting into other friction points very soon after. So we want the teams to own the pipelines themselves, to kind of own the agents that they're running with the right support from the delivery infrastructure team.
This episode of Software Engineering Daily is sponsored by Datadog. Datadog integrates seamlessly with container technologies like Docker and Kubernetes, so you can monitor your entire container cluster in real time. See across all of your servers, containers, apps, and services in one place with powerful visualizations, sophisticated alerting, distributed tracing, and APM. And now, Datadog has application performance monitoring for Java. Start monitoring your microservices today with a free trial. And as a bonus, Datadog will send you a free t-shirt. You can get both of those things by going to softwareengineeringdaily.com/Datadog. That's softwareengineeringdaily.com/Datadog. Thank you, Datadog. There are antipatterns that enterprises can stumble onto using if they don't have the right best practices around continuous integration or continuous deployment. One of the enterprise-wide problems that I've read about is the idea of having this enterprise-wide integration test environment that's like a staging environment, but the problem is that everybody in the organization shares the same, quote, staging environment. Why is that problematic? What's the problem with an enterprise-wide staging environment?
Yeah, I think it's just fundamentally anything central to me, it's a bottleneck. It's going to cause some bottleneck for somebody along the way. So whether it's a central CI server or central staging environment. So usually with the staging environments, you have different teams that are pushing code into that, bringing the services up or down. They have different data states. And what you have very soon you get yourself into is that you have dependency to the rest of services. And the way you have written your test or your test structure, you're doing this sort of kind of wide integration testing that assumes the data that you need is there, the state is there, all the downstream services that you have that are up and running. And this volatile environment that everybody's changing and touching wouldn't give you the known state that you rely on. So it's unrealistic. So what happens is you have to kind of schedule now access to this central environment so that you can have a known state to start your integration testing from. And from there, you can imagine that you will be on the queue and you only get a very, short time slice to access that kind of server and all the resources that need to be set up. Also, it's very expensive. Usually, when you want to mirror the production environment, all the systems that you depend on to run these kind of wide integration tests, sometimes they, cost millions of dollars. Just having copies of it running could be expensive, and maintaining that could be expensive for the enterprise.
Yeah. So you're saying that the alternate model is you have some image of the production environment and you find a way to spin up your own personalized fork of that image that has your own changes on it, and then you can run your continuous integration tests on that forked image with your new build.
Yeah, that's to start with. I think more importantly, I would say let's move away from this idea of integration testing and integration testing just before release. So move to the idea of more kind of localized contract testing. So, it's been a few years that we've been practicing consumer-driven contract testing exactly for this purpose, so that every service can have, or every part of the code can be independently tested and released with a good level of confidence by running the tests that are written by the consumers of your application or your service. And you run those as part of your pipeline against your service in a localized fashion. You don't have these large number of integration testing that would need an integrated environments. So consumer-driven contracts is an approach you can use. And also on the other side, you can run these kind of synthetic transactions and tests in the production environment and focus on time to recovery. So if something's not working, be able to recover quickly. So recovery versus kind of prevention.
What are some other CI/CD anti-patterns that people have as they're trying to migrate their enterprise to a place that uses, some of the modern software technologies?
We actually have, I think, few of them on our tech radar in the hold ring, which means try to avoid. One of them, if I recall correctly, it's called CI Theater. So the idea is that the teams, kind of set up the CI server and they have some tests that possibly running. But although there is a CI agents running and there is a pipeline, the code doesn't integrate frequently. So there is a large gap between the check-ins and commits. The code might be on feature branches that are not being integrated into the trunk. The other pattern is, having a central CI server that everybody's using and having a central team to look after it and to create the pipelines, which will create a bottleneck. So all of these really are anti-patterns because they're against the fundamental concept of continuously integrating your code all the way from your commit to production and delivering to production. I think these are a couple of ones that are on the tech radar.
Got it. I'll put those in the show notes. What about security? What are the security issues that an enterprise might need to address as they are updating their platform?
Sure. Security is usually a function that kind of get involved in the development quite late. And it's about how I'm going to stop you from putting your code that might have some vulnerabilities right before you just release your code. So they get involved quite late in the process, and their function is really stopping code to go to production to, possibly make the environment unstable or insecure. And that is really changing. So for us, the shift would be security concerns get considered much, much earlier in your development process. So as you write stories and develop, the functional capabilities of the application you're building, you also think about the threat model. You think about the security stories and consider them just as part of your, the feature set. So security would get involved quite earlier, and their function would be, how can I enable you to build security, into your application? In an enterprise, the traditionally security has been built at the perimeter. So we have some sort of a firewall and some form of a zoning, and across the zones, we put some sort of a security in place, and within it, everything's fine and, secured. So you don't have to worry. And that's completely shifting because, with kind of more microservices architecture and distributed architecture, you're moving into a kind of zero trust environment that you don't trust, you always validate. So security gets pushed from the perimeter to every service and every application that you're building. So security features that you need for, to authenticating and authorizing the calls coming in has to be built into your infrastructure for developers to kind of seamlessly use it. And that kind of leads into kind of interesting patterns of implementing that and providing the infrastructure to support that. And yet, have a frictionless, seamless experience for the developers.
What if an enterprise has some significant overall architectural problems? Like you hear this referred to as the big ball of mud, for example, just this monolithic situation where there's lots of tight couplings and it's really hard to figure out where to even get started. How should an enterprise approach that issue?
Yeah, I mean, ball of mud, big monoliths, and they could be, systems that are 30, 40 years old, or they could be systems that are 10 or 15 years old and they have the same characteristics. Usually the enterprise, and that's, one of the problems that they have. And the other end of it is that they have too many systems that do the same thing. I remember a CTO of the company that I worked with, every time I went to his room, he had this giant kind of diagrams of all the systems in the enterprise, which had, I don't know, hundreds of tiny boxes. And each of those tiny boxes did something really, really important. And probably 10 of them did almost the same thing, but not quite the same thing. So the entropy that you see within, the software and architecture entropy you see within the enterprise is quite complex. So on one end, you have the ball of mud, which is, these kind of large systems that are hard to break. And the other end, you see this kind of fragmented technology that they kind of do the same thing. They do by through acquisition, or building new technology, but not quite finishing what they were doing. So you have the new system and old system, they kind of run at the same time. So these are both the two ends of challenges that we see at the enterprise. Where you get started, you get started where it matters. And by that, I mean, you are usually enterprise wants to change the technology because they want to go faster. They already have the scale to some extent. They have found ways of scaling the organization, but they need to go faster. And you start with, okay, what changes are coming down the pipe from, kind of the business and product point of view, and what capabilities are getting changed more often. So you can talk to the business, find out the capabilities that they want to change. You can also do the other end. You can do social code analysis on the, let's say, monolith to see what parts of the code are changing more, to find out where it matters, to start extracting that. And then with extraction, again, you have to be very careful because there are people in the organization that are very biased to the existing code because it's the code that, they put their hearts into. It's their baby, and you're coming and telling them your baby's ugly and it has to change. So you need to kind of inject some new blood and new thinking into existing organization, take advantage of the knowledge that this experience is already there, but bringing some new thinking to decide whether extraction and the reuse of the code out of this ball of mud is the right approach, or is it a rewrite the right approach? And I can tell you that most of cases, rewrite is probably the right approach unless you have a very complex IP that you need to retain. And you kind of rinse and repeat the process by finding the next thing that matters more, build the test around it, put all the good software engineering and continuous delivery practices for that part of code so it can be independently released. And you redo that. And one thing that really matters in terms of, all the things that I'm kind of describing are evolutionary change. They're not kind of revolutionary change. But if you're doing evolutionary change, we have to be very conscious of what is the smallest unit of change that can get me closer to the goal and the vision that I have. And that's something I've seen in the migration strategies. We start with something, we say, okay, we want to, let's say, extract capability X. Let's say it's a big monolith. We say authentication of the user, the security is the first thing we need to get right. So let's build an authentication service, authorization service outside. What happens is we don't fully complete that unit of migration. And by that, I mean, changing the consumers that are, using the existing application as well as changing the application itself. So what you end up with is essentially two patterns. The old way of doing there's still part of your organization or part of your applications that you're doing the old way of authorization, authentication, and there's part that are doing the new way. are we really closer to the final goal of, reducing the tech debt to be able to go faster and, reducing the cost of maintenance? Probably not. We now ended up with 2. So we added probably 4 more boxes on top on that CTO's kind of system diagram. So yeah, it's interesting, but it takes a lot of, I guess, discipline, practice, and collaboration across, products and engineering and the support of the leadership.
It sounds like you've seen a lot of monoliths and big balls of mud.
Yeah, almost everywhere.
Yes.
Yeah, it's very easy. It's it's a path of least resistance.
It is.
You go in, you want to add a feature. Should I go build this as a separate unit, or should I just band-aid and add a line of code, a case, a new function? It's a path of resistance that gets really sticky after a while.
And so you describe, I think, 2 ways of dealing with it. You could break off functionality into some new service, or perhaps you can do a complete rewrite. And there's different gradations of both of those. What about the approach of setting up a facade in front of the monolith and basically having a different API into the same code base? Or maybe you could have like a GraphQL server that interfaces with the monolith and basically makes the API surface a lot easier for engineers to deal with, while also satisfying the legacy consumers who want to access that API directly.
Yeah, that's a very good point. I think that's a very good first step. And we see a lot of clients that they go as far as that step. So with Facades, absolutely, as you said, you can kind of start building that new APIs and new interfaces that make the consumer's life much easier. You can, separate your kind of legacy from your new modern way of building the applications. The challenge there is that you can go so far with that approach. And by that, I mean, very quickly, you need to either modify a capability, add a new feature that unfortunately is locked in that monolith. And the reason that you want to migrate from the monolith, because the monolith is hard to test and hard to change and doesn't lend itself to continuous delivery. So you're very much back to square one of, I need to change my monolith, and it's now going to take, 5 months or 4 months and that many dollars to do it. And your digital team is being kind of stuck with that dependency. So though it's a very good first start, because you can isolate your channel applications, your mobile applications, your consumer facing applications. And it's a good way of kind of really finding out some of the limitations that the legacy system have. For instance, a lot of the telcos go through this process because they have an e-commerce site that they want to be able to sell different products and packages. And iPhone comes out, and the sales of iPhone brings out the whole site down, because even though that you have APIs and Facade APIs that you built around the monolith is not built. The legacy system is really not built to take the throughput and the load that the system goes under. So you have to now reinforce and protect those facades and build throttling in place between, the legacy and so on. And the next step is, as an example, in the telco industry, almost every telco wants to bundle different packages, different data, mobile, broadband, satellite, and create different offers. But they want to be able to experiment with those. And, the marketers want to be able to define different packages and put it out there and see how consumers respond. To do that, it's very hard to do that at the API level. It gets really messy very quickly. So you have to change those core systems. So that change needs to continue. And there are, kind of patterns of extending that facade to become these autonomous bubbles in a way that, you can try to extract capability and build capability outside of the legacy. But it's absolutely a great first step.
There are so many organizations who they started building their systems, like you said, 20 years ago, 30 years ago, at a time where we didn't have this mental model of saving all of our data, putting it in a data warehouse, and being able to extract insights from it, because I think companies were so busy just trying to handle the day-to-day operations, they didn't even think about saving that exhaust data and trying to run MapReduce jobs over it or anything, because we didn't really have those technologies. Nobody was thinking about that. But now you fast forward to 2017 and we start to see, a company that is, let's say, a manufacturer of toilet seats even. If you've got a factory that is running software that's manufacturing toilet seats, you actually have lots of interesting data. You have data that you could use to save money further down the line if you're actually saving that data. And so many of these companies, they're thinking about, okay, how do we re-architect our systems so that we can aggregate this data and we can make it available to other people inside of the organization as a data lake? They're just like totally unprepared to take advantage of this data that they have. They don't have it available. They don't have teams that are available to do data science on it. What can these companies do to start to think about building that data pipeline?
Yeah, absolutely. That's a super important point. I think just stepping back for a moment and thinking about, when we get to the technology side, but I think what you mentioned, it's such an important point because with the change in the industry, with the digital natives coming and, threatening the big enterprises can be in a very favorable position if they can unlock their data and assets and really create and join business ecosystem. So what we see with, a lot of enterprises, they're thinking about their business models that, what can I unlock in terms of data, insights, and assets that I have that gives me a competitive advantage to a new kind of digital native startup that is really disrupting my business? And how can I create a business ecosystem outside of my company, inside of my company, but also outside of my company? So using this data, I can go into partnership or go into a kind of a bigger network of economy and business with syndicates. So unlocking that data is super crucial to really shape your business for future. Coming to the technology side of it, that's a problem with all organizations. Like customer loyalty, brand, information about your customers are the most important assets that you have. And I can tell you the number of times that we talk to a CTO and they will say, we have no idea how to get to this information. If we have any information about our customers, we probably have to go talk to a developer and he would dig around or she and find the information that we want. So they self-serve kind of data engineering practices. It's the foundation for it. Be able to build APIs to expose the data as the first step. Be able to, because a lot of the organizations run kind of back jobs that, go to different databases and extract the data out. They are kind of working in offline mode. They work in a batch mode. So we want to move to more of the stream-based exposure of the data, and not just exposure of the state of the data, it's exposure of the events as they occur on the system. So it's very, in a non kind of invasive way, how can we change even that monolith that when a change to its data store happening, it can trigger publishing of that as a rich business domain on a data pipeline. We will have definitely, you will need that data engineering practice and capability brought to the organization to set up the self-serve data engineering pipelines. You need to have the good domain design so that the data that you're exposing, it's abstracted well, it's secure, access to it is secure, and really allows the consumers to, process it easily. So self-serve data engineering and using that technology and opening your legacy for extension. We've had this open close principle in software object-oriented programming forever. Let's apply that to the architecture. How can I open, instead of changing my monolith for modification, how can I open it for extensions? And by opening that is, how can I expose the data in a real-time fashion into the data pipeline so that the modern applications or consumers that I have built, they can consume it, they can, infer state from it, or they can infer insights from it, or just, store it in a data lake where, different teams can come and make sense of it.
Azure Container Service simplifies the deployment, management, and operations of Kubernetes. Eliminate the complicated planning and deployment of fully orchestrated, containerized applications with Kubernetes. You can quickly provision clusters to be up and running in no time, while simplifying your monitoring and cluster management through auto upgrades and a built-in operations console. Avoid being locked into any one vendor or resource. You can continue to work with the tools that you already know, such as Helm, and move applications to any Kubernetes deployment. Integrate with your choice of container registry, including Azure Container Registry. Also, quickly and efficiently scale to maximize your resource utilization without having to take your applications offline. Isolate your application from infrastructure failures and transparently scale the underlying infrastructure to meet growing demands, all while increasing the security, reliability, and availability of critical business workloads with Azure. Check out the Azure Container Service at aka.ms/ACS. That's aka.ms/ACS, and the link is in the show notes. Thank you to Azure Container Service for being a sponsor of Software Engineering Daily. The data pipeline gets us more value out of those existing assets. And I think the same could be said of an experimentation system. If you have a way to experiment against the way that your architecture has been set up, your data, if you can A/B test against different user sets, you can find out a whole lot about where your company should be headed. And I think this can be really valuable for companies that are trying to figure out exactly how to innovate or in what direction they should be innovating. Describe the value of an experimentation system and what an experimentation system looks like for a large enterprise.
Sure. I couldn't agree with you more. Absolutely. It's really interesting. Like a lot of enterprises go through this costly, slow, and time-consuming process of approving features because building every feature is so costly. You have to bring a team together. A lot of the enterprises are working a project base. So, you have to bring a team together. You have to justify a business case that this is going to work. This is going to have the return on investment. Spend a whole bunch of money, put the feature out there, sometimes never even measure that it worked or didn't because you've already spent a lot of money on it and you went through, 6 months, 3 months, whatever cycle of approval process. In some cases, do monitor what happened, but the feedback cycle is just so late and so costly that changing direction would be very difficult. So experimentation is the foundation for kind of continuously adjusting the direction we go in, continuously adjusting where we invest money, where we kind of subtract money and don't invest money. So experimentation could be at different levels. So the technology for it could be, as simple as I am able to reroute a portion of my traffic. I'm able to, let's just step back, sorry, for a minute. I'm able to, first of all, put a piece of software out there that, it might be temporary, might be permanent, but I can quickly make a change in the existing behavior of system by maybe extending it, adding a new piece, new service, new application, and be able to route part of my traffic, a segment of my customers to this new service and be able to measure the impact of that towards the goal that I had, whether it was bottom line, whether it was the number of the customers that clicked on that particular feature or purchased the product. And most importantly, be able to either discard rid of the feature that I had because it didn't work and I need to iterate over it, or double down on it and, push it all the way to production and make it kind of production ready. All these things that I mentioned, they sound very simple, but structure and the infrastructure that you have to put in place to support that is a fundamental change that needs to happen across the board, needs to happen in your infrastructure. And I've had, firsthand experience of this, that, we've been able to, let's say one of the unlocking capabilities that you need to have a good set of APIs. APIs that people who want to do the experimentation can easily discover it, can use it. It doesn't need to talk to 10 different teams to figure out what this API does. So it's simple, well-documented, it's self-served. once you're there, you need to have, your delivery infrastructure set up in a way that, again, in a self-serve way, I can push my application to production, and I don't have to go through a long release cycle. I don't have to wait for the host to be set up. The networking and the routing, again, I need to be able to configure that ideally in a self-serve way. So the team that is doing the experiment needs to have all these capabilities in kind of as a product, essentially, available to them to be able to go through that experimentation. Need to have a way of then be able to capture the metrics, be able to visualize the metrics and make decisions. And it's really sad because sometimes we go through a lot of hurdles and do experimentations, and we actually find out, that little, very, very small change could make such a big difference in the bottom line, but we don't have the capability to make that a production ready code that can scale and can consume all traffic. So even the experimentation is successful, it gets kind of discarded and it goes back to the production code release train, which does defeat the purpose of the fast feedback loop.
I want to shift to talking about some specific technology, some more modern technologies, and starting just with cloud. So if we take the large enterprise, like a toilet seat manufacturer, how readily are large enterprises adopting cloud? Because they've got 20 or 30 years of infrastructure experience with their own servers. Are they adopting cloud? Do they do anything with the cloud?
Yeah. I mean, it's interesting. We have shift, kind of at least in the mentality and the approach from, enterprises a few years down the track, years ago, they were questioning why cloud and why us and what we should put on the cloud, to saying, why not cloud? So we see cloud first across a lot of the companies that we work with. And their approach is, let's just start with the new pieces of the software. So all the new capabilities, they start building kind of the cloud native applications and put it on the cloud. What we see is also a shift from kind of application runtimes, the Cloud Foundry kind of application runtimes, and building 12-factor apps, which is great if you're writing new applications, but it doesn't really work that well when you have legacy systems that they just haven't built that way. So moving from kind of application runtimes in cloud to container runtimes on cloud. So Kubernetes was a big theme on our radar this kind of on this edition of the radar, because the companies see more value to work at that level of abstraction so that they can containerize their legacy systems, have more control over the configuration of their environments and dependencies to the legacies. So that's another shift that we see. But it's really it's cloud first is one of the top 3 kind of initiatives within the enterprises.
So you're seeing clients adopt Kubernetes?
Yeah, Kubernetes seem to have kind of got the right level of abstractions and the right level of control, and obviously the evangelism behind it and the developer support and the community support. We've seen clients are leaning towards that much more easily. And I mean, it's clear where the industry is heading as well, with all the kind of the modular architecture that the Kubernetes has, and it allows the cloud providers to kind of adopt it and plug that into their infrastructure. We see kind of managed Kubernetes. I think Amazon just recently in reInvent announced their own. We have used GKE for quite a while. Yeah, so and Pivotal, I think they announced their container runtime. So big players and big cloud providers, they provide the managed Kubernetes, which takes away, the overhead and the cost of them installing and managing the cluster. And for enterprises, it seems to, and especially with the legacy system, it seems to kind of give them the right level of control that they need for the older pieces of the software.
And they're typically choosing to go with a managed Kubernetes offering, or do you know what they prefer? Do they roll their own, or do they go with a managed Kubernetes provider?
I think
too early to tell.
Too early to tell, and it really depends on the maturity of the organization. What we encourage is, consume first, build next. So, invest your energy and effort and money instead of building bare metal, building, features that matter to the mission of your organization. So, manage Kubernetes as opposed to hand-rolled versions, because there is overhead in managing that.
Of course. There's another topic of discussion that I saw on, I think, the most recent ThoughtWorks radar, which was that a lot of people are using Kafka to recreate some of the patterns of the enterprise service bus. And we've done some shows about this event sourcing pattern where you publish all of these events onto Kafka, and Kafka becomes your event streaming source of truth. Anybody that's curious about that can check out those episodes. But what was the enterprise service bus pattern? How does that relate to Kafka?
Sure. I think it's more the organization side of it. So Conway's law, or reverse Conway's law, your organization reflects your systems architecture and vice versa. So in this case, we see kind of the Kafka becomes your backbone, and rightly so, it becomes the backbone of your integration across your services. But then what happens is you end up with a central team that is managing kind of all the infrastructure around it, the topics and the channels that you need to create, and an ownership of the kind of the data and the schema of the events and so on. So then in itself, it's become kind of a monolith and a centrally controlled, really important part of your architecture. So I guess what we're saying is that that's perfectly fine to use Kafka, architecture and streaming on top of it as the backbone of the integration. If you have, pops up type integration patterns, but leave the control of the events and the topics and the management side of publishing and the consuming of those events to the domains, to the services that own those domains, and to the teams that own those domains. So distributed kind of ownership of that infrastructure, and giving control to the teams to define those rich events that is specific to their domain.
Do you see it as an anti-pattern, this idea that we're putting a whole lot of centralization into that central Kafka cluster? We're publishing all these events to the central Kafka cluster. It sounds almost like the shared staging environment that we discussed earlier with that central dependency.
Yeah, absolutely. I mean, if it really depends how the distribution and how the communication across the organization works. You may have still a central cluster of Kafka, or any other piece of infrastructure. It might be an API gateway that you decide to configure in a clustered configuration. But how much of the control you expose as APIs, as again, self-consumed way of changing the configuration to the teams themselves. So I think it's a tension, right? It's a tension between some piece of infrastructure that needs to have some sort of a, central deployment model versus that piece of infrastructure still releasing control in a secure and reliable way through APIs, through automation to the teams themselves, and get that kind of architecture right and get that tension right. It's hard.
What about logging and monitoring? If we're talking about these large scale enterprises, and I think logging and monitoring is maybe another one of those things that the company doesn't have because it's sort of like the data lake. This is, these companies were established before there was really good monitoring and logging tools. And then, now maybe they want to update their infrastructure to use Splunk or Prometheus or the Elk stack. And they don't know what they should adopt. They don't know how they should adopt it. What advice do you have to enterprises that are trying to get better observability out of their stack?
Yeah. The first one, learned from experience, is that do not build a piece of software without debuggability and logging built into it. Actually, some of the big enterprises that I've worked with, it's interesting when they've moved architecture, from the existing kind of monoliths that they had or layered architecture to microservices. One of the first, capabilities that architects think about is how I'm going to get observability in place. What sort of libraries or sidecars, the new flavor of doing this I need to put in place so that with the first piece of code that goes into production, I can get reports out. I can get information about the health of the system and all the different metrics that indicates the health out in a distributed fashion. So my, I guess, advice would be, one of the first things you think about as part of your migration is distributed debuggability and logging as a way of debugging, because the old way of debugging code is not going to work anymore in a distributed fashion. And really, the technology of choice, anything that lends itself to a modern distributed architecture. This year, I think it's a year of service mesh, personally in favor of the shifts that's happened, because previously, we would have been building service harnesses or chassis that implemented the libraries for, getting the kind of observability and metrics out. Now we can kind of extract that from the application itself into the sidecar and deal with kind of polyglot environments much better with less kind of cost. So yeah, think about what technology plugs well into that distributed, logging. So adopt standards, open tracing as a de facto standard for instrumentation, for distributed instrumentation of the code. Prometheus, it plugs well right now with the kind of implementation of the service mesh that we have. And really, I would think, have empathy for the developers. So make the life for the developers as easy as possible to both expose information that they need, but also consume. So how, let's say they're using Splunk, and the developers should be the main consumers of those dashboards, knowing, and learning about the health of their system. So how can they automate creating those dashboards the same way that they, write code? They can have the right configuration and the automated deployment of the configuration for the dashboards. So both the production end and the consumption end of the state in terms of debuggability is important.
Zhamak, thank you for coming on Software Engineering Daily. It's been great talking to you.
No worries. Same here. Thank you so much for having me, Jeff.
GoCD is an open source continuous delivery server built by ThoughtWorks. GoCD provides continuous delivery out of the box with its built-in pipelines, advanced traceability, and value stream visualization. With GoCD, you can easily model, orchestrate, and visualize complex workflows from end to end. GoCD supports modern infrastructure with elastic, on-demand agents and cloud deployments. The plugin ecosystem ensures that GoCD will work well within your own unique environment. To learn more about GoCD, visit gocd.org/sedaily. That's gocd.org/sedaily. It's free to use, and there's professional support and enterprise add-ons that are available from ThoughtWorks. You can find it at gocd.org/sedaily. And if you want to hear more about GoCD and the other projects that ThoughtWorks is working on, listen back to our old episodes with the ThoughtWorks team who have built the product. You can search for ThoughtWorks on Software Engineering Daily. Thanks to ThoughtWorks for continuing to sponsor Software Engineering Daily and for building GoCD.
Wow!